Hey, everybody. I'm Jen, and you're going to listen to me for 15 minutes.
Oh, no.
I promise I'll make it worth your while. So my name is Jen Indovina, and as you heard, I'm a visiting lecturer in engineering and 3D digital design at RIT. But I'm mostly here tonight because Lori is my mom's boss. And my mom said, Jen, you're doing this talk, and you don't say no to your mom. So I was the faculty advisor to the RIT Multidisciplinary Senior Design Senior Capstone Project. This is me as well as my students at the Johnson Space Center last April, where they were demoing for the Artemis astronauts their planet and base training system. So as you can see in this photo on the left-hand side, is one of the Crew 4 Artemis astronauts, and actually the head astronaut, Joe Arafo, and on all the way over to the opposite side is me hugging uncomfortably one of the other Artemis astronauts. So the reason I'm showing you this photo like this, which looks sort of like a marketing photo with the team, is because none of the photos that we took of the astronauts actually training with our system are allowed to be shared publicly because this is technology that's being used to train current astronauts for current and upcoming missions. I apologize. However, I will be showing you demo photos of that system being first tested on the NASA doctors themselves. So the doctors were the stand-ins for the astronauts. As you can see with this photo here, one of the RIT mechanical engineering students is wearing a bunch of body sensors placed in the torso, the thighs, the ankle, as well as wearing a VR headset and 2 hand controllers. This makes up what we call the planets, and yes, it's an acronym because NASA loves an acronym, that stands for portable, we'll get to it. Anyway, this project was part of the NASA X-HAB Moon to Mars missions, which was part of the University Challenge back in 2021. We are now in our 3rd year. NASA has continued to grant this project with funds, and we've now branched off, like a successful TV show would, into having a new grant with NASA for the X-HAB missions to develop similar sensors, but for astronauts that will have extended time living on the moon base or Mars base Alpha. So like you can kind of understand, under the whole umbrella of the X-HAB Moon to Mars missions, we are now participating in a few avenues. But what I'm going to mostly be talking about now is the pre-flight and post-flight astronaut conditioning and recovery system. So this particular project was called the gamification of VR balance trainer for proprioceptive conditioning. We just love to make stuff really hard to make. Basically, it's a VR game with real-time sensors that capture the center of mass of the astronaut. We give them a difficult VR game to play. We give them a portable balance board or an extremely complex rig. The game itself takes inputs from the sensors that it uses to calculate the center of mass of the astronaut and uses that in real time as feedback for the game to make the game more complicated so that we can attempt to condition the astronauts to have better balanced recovery. Since the beginning of us putting astronauts into space, proprioception has been an enormous challenge. We don't tend to see it in marketing photos or in public video, but the astronauts struggle with walking when they return from space travel. This was all the way going back to the Gemini missions. It took John Glenn about 3 months to learn how to properly walk again. They didn't let you see that in photos, but he was being carried from interview to interview. He was being carried in and out of airplanes. He really couldn't walk when he returned, and it had nothing to do with muscle mass and everything to do with his inner ear. Your proprioception, what happens over time is the little fluid that your inner ear bones, those little 3 bones in your inner ear, that fluid, the viscosity of it changes in space over time. It almost thickens or hardens. So this actually is similar to the bell curve of life. When we are babies, the viscosity of that is a bit thicker. And when we age, it's a bit thicker, which is why our balance is a bit off when we are younger and older. And the viscosity of it is the best when we're at our peak median age. So that's what happens to astronauts in space. that viscosity changes. So what the NASA doctors are hoping for is that we can train them. We can make their balance much stronger, which won't stop them losing their balance, but it may make their recovery time much faster, which is very important because astronauts are being used for long-term space flight missions with very short recovery times. So the students, like I said, built not only the VR game. So this was not just an engineering team. This team that I managed as the faculty advisor included students from game design and 3D digital asset design, right? So making game assets, as well as a multitude of engineering students. So mechanical engineers, biomedical engineers, an exercise science student, as well as a psychiatry student. We wanted to look at the psychology of it too, because anytime you're training an astronaut, you have to consider the behavior science as well. So this particular project, the students built the VR game themselves, as well as the mechanical balance rig that enabled them to test the game levels that they were developing, and the portable wearable sensors to calculate the astronauts' balance scores for the NASA neuroscience doctors for their pre- and post-flight medical records. So if we take a look at the base, this is what the students built to test their game levels. So as you can imagine, you would put on the VR headset, you'd be strapped into this moving floor that was connected to two linear actuators, of which the angle of motion of those two actuators was produced by the game. So like I said before, the game learns your score and it continues to make the game harder and harder and harder, and it makes those actuators move more and more and more. So it's meant to put you off balance and make it harder for you to retain your balance over time. So the students designed everything from the PLC and FPGA controllers for operating the linear actuators to move the floor, as well as all the construction details. They did all the welding. They did all the metalwork. They built everything, and they did all the safety specifications so that they could pass human testing, which is IRBs and stuff like that. It's a lot of work to do in a year for these students. Now, this is a look at the internal accelerometers of those wearable sensors that the astronauts were making, because that wouldn't be enough to just build that mechanical rig for these students. They also built these custom wearable PCBs, or single board computers, that had the accelerometers, and those accelerometers would basically send that information to construct a skeleton inside the VR game so that they could calculate that center of mass and give a appropriate balance score. Because it's not enough to just like pick up a gem and use that to increase your point count. You have to keep track of whether or not the astronaut is falling, or how much they're moving away from their center of mass. So the students had to parse through all of this very boring array of information and use it to come up with an interesting and easily understandable, which is very important for NASA, system for the NASA doctors. So this is what the students came up with. They came up with a visualization of the balance score in MATLAB. So all of this pops up when you play the game. So the doctors actually see this as an executable. So they just run the executable, and the astronaut puts on the VR headset, starts playing, and then these MATLAB, basically these files are generated for the doctors and stored for them, so they have them in the records. So what we are seeing here is how much the astronaut moved away from the center of either playing on that portable balance board or on that very large mechanical rig, of which you can kind of see another visual representation over all the way to the right. That was us splitting up that floor of the mechanical rig. And as you can see, mostly on average, people fall forward when they are basically put off balance. And that aligns with a lot of the tests that NASA has been doing since the 70s into attempting to work on proprioception by doing balance training. The actual design of these sensors themselves were completely custom. There were no electrical engineers on this team. There were only computer engineers. So as you can see from this hand-drawn schematic, which made me want to rip my hair out, the students had to come up with an idea for how they could make this extensible for NASA. Try to find off the shelf components and only customize like a certain aspect of it. In this case, the PCB, to try to shrink down the size of the sensors so they would be enjoyable for the astronauts to wear for extended training. I don't know if you guys know this, but astronauts' days are extremely scheduled. And some the more popular doctors at NASA will do things like if they have a 15-minute test with the astronauts, they'll actually schedule with the astronaut handlers that it's a 45-minute test so that they can give the astronauts like a free 20 minutes to like play on their phones or call a loved one or do whatever they want. That's how regimented their lives are. So anytime a NASA doctor can give an astronaut like a free 5 minutes by lying and saying their test is a bit longer, they do that so that they get more popular with the astronauts. Just like you guys would like that sort of inside story. In order to do the calculations, what happens is you basically step onto the floor or the portable board and you turn the game on, and right away the sensors start collecting data in that data stream you saw before, and the game level obstacles will force the player to squat or to pick up things, to dodge obstacles, and every time it will update that balance score. And like I said before, the difficulty will scale as you continue to play. So future work here is for the students to continue to develop better graphics to make the game more enjoyable for not only the astronauts, but for the doctors who have to actually integrate the data into their medical records. So this was some initial testing with the game students. As you can see, very rudimentary GUIs for game control. But this is part of the code reviews that the teams would do with NASA. They would present these levels and the designs that they were building and get feedback directly from members from the Human Performance Lab at NASA at Johnson Space Center. This is a playthrough of one of the first generations of the game. I can't show you the latest generation of the game for the same reason I told you as before, because it is being used by active astronauts, and that protects it. This was an older version of the game, so I can show you. As you can see, it's very dark, and that isn't just because the students sucked at placing lighting in the game level. It's actually because NASA doctors requested that the game level be sensory depriving. There are aspects of space travel which push the human experience to the limit, and they want to psychologically test things like darkness or extreme exposure to light, and then test all of your human, your normal, what your blood pressure or your normal conditions, and use that to sort of get baselines for the overall health of the crew. The 3D students, the art students on the teams would do things like develop assets for the level. So as you can see in the upper right-hand corner, that's a lot closer to what the level looks like now. And if you're wondering, yes, the theme is based on the Indiana Jones games. So each level of the games is based on a different Indiana Jones film. And the reason for that is when the students met with the NASA advisors and said, all right, well, we're thinking about concepts for the games. What is it that astronauts like? And one astronaut who was speaking for all astronauts said, tacos and Indiana Jones. So the kids landed on Indiana Jones because they could not come up with enough game concepts for tacos, unfortunately. So the students that were working on the game arts and the game level would do constant reviews with them as well for placement of obstacles and objects, how far to push those tolerances of testing the astronauts' ability to balance, how far do we want to push them? Do we really want to push them to fall over? Or do we want to get that recovery calculation? What's important for their training? So this is the students, again, at the Neuroscience Lab in Johnson Space Center, preparing to demo this setup for the NASA astronaut doctors and train them. So this was basically the planets demo. So that big rig that you saw, that stayed at RIT so that the students could continue to develop more levels and more playable elements of the game, as well as additional generations and refine the design, which is what this year's current team is doing. Let's refine the design. This portable version, or the planets aspect of the training system, stayed in Johnson so that the doctors could use it on the astronauts. So this is the students setting up and testing the game with the head NASA neuroscience doctor in the ASCR lab, which is astronaut strength conditioning and recovery. These are the doctors that fly to Kennedy right before takeoff, and once they splash down and come back, and immediately get them walking again, breathing right. They assess their condition and they attempt to accelerate their recovery as fast as possible. And what we heard from these doctors was a few really cool takeaways that even surprised me when I think of NASA and I think of technology that will help us become a species that is lives off of our planet in the future. And the first one is keep it simple and make it work. So when we were down there, we were treated to a visit to one of the labs where they test all of the machinery for the gym equipment that is on the International Space Station currently. So they have a similar setup at Johnson, which the students and I and the other faculty associated with this team got to try out. And we learned some very interesting things. Like, for instance, if you're using something like a reverse bench press in space, it can't in any way be attached to like the exoskeleton of the International Space Station for a couple of reasons. And the main reason is, what do you think? Transfer of motion, correct, right? Transfer of force motion, right? So as soon as you start moving on the, as soon as you start moving the bench press, or as soon as you start running on that treadmill that keeps you locked in fighting gravity, you are transferring some of your force to that exoskeleton or to whatever is attached to it. And literally the astronauts were shaking basically fixtures and hardware loose on the ISS. And they had a few very close calls because one astronaut Kelly in particular, was brutal on the stationary bike, and it broke the toilet. So again, another insider story. Another insider story for you. He was in space for like 300 days and everybody was pissed at him. Anyway, okay, moving on. So one of the very cool things about this project too was that the students completely thought out of the box to make this a portable solution. And this turned out to be one of the most incredibly favorable things for the NASA doctors. They were extremely excited that, in the words of the head doctor from the ASCR lab, we could just put this in a backpack, take it down to Kennedy, and start testing them after they splash down. Like, they can immediately get their hands on the astronauts and start testing them and getting data that they can collect and then graph and then use. And they love to plot, right? Because originally what they would have to do is wait for them to go through their time in quarantine or their accelerated quarantine, because we figured out ways to do it faster than we used to. But then they'd have to be transported to Houston. And like I said, their days are regimented and everybody wants access to them. So the doctors love it that they could get their hands on the astronauts as soon as they come down and immediately start their recovery training with this portable version. And in it, there's something else that has been fascinating to me, and I really enjoy it, which is NASA's dark sense of humor. When they would meet with the students, they would consistently terrify them that their technology was going to be used on astronauts now. So in one of the meetings where the students are doing what we call the handoff, right? So the GitHub repository has to be perfect. The documentation has to be perfect. The executable has to work when you double click on the .exe. You can't have a batch file come up with an error, right? Everything has to be super tight. The kids go through the presentation of delivering the base and the planet software to the astronauts team down in Houston. And the head of the NASA Neuroscience Lab, Scott Wood, who is continuing to be our contact for these new projects going forward, said, "I just have to tell you guys are single-handedly revolutionizing spaceflight." And all the kids shit their pants. I'm sorry. Like, they just lost it. They were like, "Ah, like, my software, stop it." So it's been an incredible experience. It's been an amazing project. We can see this and a future pathway to this technology being meaningful. I thought it would be fun to show you guys that there is an aspect of being an astronaut that has to be fun, but it also has to be challenging. And the NASA doctors themselves really enjoyed working with the tools that could be used for them. In this particular case, the head doctor really liked it until he saw his score, and then he was pretty pissed off because I think he got a D. And actually, one of the other doctors, she got a B, and he was furious because they're rivals. But astronauts are extremely competitive, and so are all the technicians, and so are all the doctors. It's just compete at NASA. So this is our team down there that we work with. Scott is on the left, and Tim McCauley's on the right. And another point I wanted to make is there's been a lot of talk lately, right? Like how much of NASA is NASA, and how much of NASA are these for-profit companies, right? That seem to be doing everything from making the rockets to making the next generation spacesuits. And when you talk to the old ducks, the people who have been at NASA forever, including the past NASA director, who had been the director of NASA for decades, they're positive about the future. They're excited about collaboration. And for them, they see NASA as being a skunk works where they can test out things, they can take risks, and they don't have to worry about the for-profit motive or the budget as much. They like to be able to push off some more of the commercialization and make this at scale to the for-profit companies or to other countries. So I just thought I'd share that as an aside. So here's a couple cool pictures from part of the neuroscience labs at NASA. So on the left, you can actually see me testing out a proprioception test from 1980. So as you can see, instead of a VR game, I'm standing on a platform. Scott's about to run the DOS software to move that ground, but he's not actually going to move the ground. The ground is just going to measure me. He's going to parallax the scene and move that sort of Palm Springs-like colorful horizon image that I'm looking at. That was the way that for 40 years, they measured astronauts' balance. I would say we've leapt in this technology, and we're not stopping. In the middle, how many of you guys have seen Ready Player One? The Steven Spielberg movie about the future and the metaverse and VR, whatever. Okay, so do you guys remember the Una treadmill? You run in any direction in the metaverse, right? You're not bounded by gravity in any way. That actually is the prototype that was developed for the film. NASA has it, and they're using it to train the astronauts so that they can understand what it will feel like to be suspended for long periods of time, or to have training mechanisms on the moon base or on the permanent Mars base like this. This is the future of their strength conditioning in space. And it came from a Spielberg film. And all the way over on the right, you can see some of the zero-G training where they use resistive bands. Again, old tech from the 70s. This is the Gateway. How many of you guys know what the Gateway is? Some of you. Some people are NASA nerds. The Gateway is our next generation international space station. It's our partnership with Europe and Japan. And we're in the process of building huge modules of it now. It will orbit the moon, and these really cool rovers will take off from the Gateway called DRATs. They will land on the lunar surface, and those rats will basically be housing for the astronauts. They'll move because they'll be rovers. They'll also be their lab facilities. And NASA also wants us to put all of their training equipment and everything they need in those rats, right? So they're basically going to move from the space station to being in these portable little modules that will move them down to the surface so they can do extended EVA testing on the lunar surface as part of us moving towards permanent moon occupancy. So everybody loves a team picture, but I took this photo, so I had to draw myself in between Scott and Paige all the way over to the right. So that's me in white there with my team. I thought it'd be cool to point out that even though this project has ended and this team has ended, not everybody is done with NASA. All the way over to the right, who I'm hugging with my little white stick hand, is Paige Manley. And Paige not only designed our team patch, which was on the first page, but she's also now a NASA Psyche intern for their art education and outreach. So she's migrated out and sort of elevated into NASA. And now having a bridge between the X-HAB missions and the Psyche missions is extremely exciting for everyone at NASA, because they love it when we collaborate and when we can see a tie-in between a mission like Psyche, which, how many of you guys know what Psyche is? We're considering mineral harvesting and spectrometry of comets. Does it make sense for us to go into space and harvest minerals and non-renewable resources from comets if we can do it? That's basically the Psyche mission. So basically one of our satellites is going to go up shoot around and use the moon's gravity for help, and get to Psyche and use a spectrometer, figure out all of the lovely tasty minerals on it. And just like the movie Don't Look Up, figure out if it makes more sense to blow it up and pick everything or to drill that we want out of Comet. So all part of a very bigger picture of human permanent residence in space. That's it. That's it. Does anybody have any questions? Yeah.
Two.
Get me. Hit me.
First one is, how in the world are we going to ever walk on Mars if it takes a long period of time for an astronaut to leave, even if it's from the moon, weeks, months to get there?
Yeah.
In 0G, they will not be able to stand, walk, or implement anything that you've trained them to do, because their muscles will have
atrophied.
Correct.
What I can say to that is NASA has, I can't say everything, but what I do know is we have started accelerating their training. So what used to be normal in their daily routine on the ISS was only to exercise for approximately 1 hour per work day. That has been accelerated to 2 hours per day. So whatever other EVAs or scheduled tests they had as being either astronauts or technicians on the ISS, exercise has been forced to become a much larger percentage of their daily schedule. And there is plan that will increase, and maybe there'll be supplements or other avenues that will also increase their athleticism in space. I will also say that when we look at Mars's gravity, the data of what we can see is that it's not too far off from ours in terms of long term, right? So we have a permanent station. Once we can get people there, we kind of know what to do with them once they're at least some close.
Before they're able to.
It may, yeah. Right now, though, with our current technology for recovery, we've sped up from John Glenn. We're closer to recovery being about a week and a half to 2 weeks now, depending on balance. So we expect that will improve greatly with even more of this proprioception technology.
Other question is that most women, the center mass is different than most average men.
Yep.
Is there a drastic, all this you've been talking about men doing the walking and the game.
But that's not the case anymore.
And that's why.
Right. I think the two current astronauts with the highest space time are both female right now, actually. Yeah. So right now, the balance score is trained off of the average body composition of all current astronauts. Sorry, I can't speak to more than that.
The question is pertinent.
Yes, it is. And we take it into account. Yeah, body compositions are different even with gender. So we do consider it. Yeah.
Are there in such a way a new technology will be able to detect our mental math changing to wherever we go on the moon, they go on Mars?
Yep.
Without losing our muscle mass. There is some kind of suit, not a spacesuit, some kind of thing to wear it. It's like Star Trek, for example.
Yeah. Well, as you can see, we're kind of building a holodeck. Yes and no. There's training. So right now the focus is pre-flight and post-flight. So it's pre-flight conditioning and post-flight recovery are our main focal points with this particular project. However, the new project that we are just starting this year is the Mars Crew Health, and that will be extended duration flight health. It will completely change, right? Our pre-flight conditioning and our post-flight recovery will look very different in terms of the exercises we do from our in-flight work. So for instance, right now we're looking at technologies that are resistive. We're also looking for technologies that are utilizing different muscular skeletal sets than what a balance, system uses. We're looking at things, I don't know how much I can tell you guys. We're looking at stuff like really intelligent pegboards. How many of you guys like gymnastics? I mean, we're looking at some of the systems that gymnasts use to train their upper body as being very useful for long duration flight muscle systems.
For instance, anybody in this group
Yeah.
wants to go on the move.
Yeah.
You would need to go this some kind of training.
You'd have to go through conditioning. Yes. Yeah.
What about the new technology?
Yeah, you still have to. They still have to exercise. Astronauts have to be extremely fit. There are limitations for everything for them, but we are seeing advances in the development of new space suits. But that has nothing to do with NASA. Does want their astronauts conditioned well. Yeah.
I have two questions.
Great.
So you mentioned that the viscosity of the air fluid increases.
Yeah.
In space. So when
becomes more dense.
When someone recovers,
yeah.
Does that fluid come all the way back, or is it?
Nope.
The fluid.
No, there is a sustained difference. So if we look at how many of you guys know about the Kelly brother experiment? So we have, okay, great. So the Kelly brothers are twins. One was married to Gabby Gifford and was a senator in Arizona, I believe, and his brother is an astronaut. And NASA did a very strong study looking at them for 370 days about what it was like with extended space flight and for this twin that stayed on Earth the entire time. And we know now there is changes to the telomeres, so the ends of your DNA strands that are altered. And we're hoping, I mean, there may be, I can't talk too much about this. This is not my area of expertise, but there is stuff about like CRISPR technology for fixing telomeres and stuff that there is NASA studies that have been done in that area. I don't know how successful the outlook is there, but I know they are looking into it.
Okay, so they can't get back to the original.
You'll never get back to zero, right? Yeah. No.
Training or.
Basically what you'll do is you'll recondition yourself to walk pretty good.
Okay.
That's our current state.
The other question I have is, I know that you can test balance for people, particularly older citizens, by having them stand on one leg. And if you close, you can get to, if someone can do 30 seconds, I think that's probably pretty good. Yeah,
and the test where you're kind of on the ground and then can you get back up without your arms?
Yeah, it's
very much like a drunk test with the top. Yes.
stand like that.
Right? Yep.
And body wants to play.
Yep.
You can get to doing that, but if you close your eyes, then.
That's why we make a dark level and a light level. Yes, we do. So we do with I didn't show you every level of the game because, like I said, I cannot show active technology that the astronauts are currently currently working with. But there are 4 game levels currently. One of them is you're on a raft, you're moving through a jungle. It's very bright. It's kind of like you're on a river raft floating through the Amazon. That is an extremely bright level. Then there is the cave mining. You're just kind of Raiders of the Lost Ark-ish, right? Temple of Doom-ish, where you're riding on the mine, in the cart. That is extremely dark and meant to be sensory depriving. So we do force the astronauts through the game levels by light control and putting different game objects in their way to create elements of stress, elements of panic, and elements of sensory deprivation.
And have you tested people like with an old-fashioned test without the electronics after their training?
So I believe Scott has. I don't have the results of those, but I believe they are still using the old tech and the new tech, and that's part of bringing the new tech into the lab as being part of their standard procedure. Just like everything else, right? Just like a university, NASA takes a long time to adopt. So the fact that we're working now and Artemis is just getting off the ground means it will keep and continue going through, follow on astronaut travel missions as well. Yeah.
So do you have like a time frame in mind about how long it would take to go through the conditioning once you get to the moon and then be strong enough to then leave for Mars? So, like, about how long do you think it would take an astronaut to, recover?
I can only talk about what they're targeting, and they're targeting a recovery that's close to Earth recovery, which right now is about 1.5 weeks. Yeah. I just don't know more. Above my security clearance. But as far as I know, they're targeting the same as what we have on Earth,
So
on Terra.
The strength probably would not, like, their strength doesn't like suffer too much, because I thought, you're.
Yeah, so I don't know how much I can go into this, but have you guys seen The Martian? Yeah, kind of what circumstances he put himself through to survival mode. Astronauts do similar stuff. So for instance, a lot of astronauts don't like using the space toilet. It is kind of meant for one gender and not the other gender. So a lot of astronauts just use the diapers. And they try to stretch that out as long as possible. And then it becomes, whose rash is the worst? When do I flip my diaper? When do I put on a new diaper? They basically will figure out how long they can stretch it with how much time they have left, right? So astronauts are very good at gaming their own circumstances to attempt to further their comfort and maximize their own experience for long extended space travel. Some of them, like, they're very limited with what sort of goodies they can bring. I don't know the volume, but like some astronauts was like, I'm not going to space without fluff. Like I need peanut butter and I need fluff. I need fluffernutters. I'm not going to space. And other astronauts are like, I don't need nothing. I'm fine with the high rehydrate rice. I'll eat it every day. Potato, fine. Like they don't. So they're attempting to create a standardized system for extremely individualized and hyper competitive human beings who are at, an interesting lifetime. So how many of you guys, what do you think the average astronaut age is currently of active astronauts? How old do you think they are? What's the current average age? 55. 55. Yes. Right. So it's older than you thought. And their body composition is that they're at peak. They're at like really good. They're very fit. So what we test on them is all sort of not what you would expect. You'd expect our test would be sort of geared younger, but it's not. So we're already thinking about like extended life in space. And what would that mean? Targeting that age range. Yeah. Sorry, were you done? Was that good? Okay. Have you looked at exoskeleton for your projects, or will it be useful for Moon and Mars if used? Exoskeletons. Yes. I personally have not worked on any of the sort of appendages or prostheses that are part of that, but it's a good suggestion because any type of sensors that you can put on the body are going to give us data about the crew. What about tech not advanced enough to sync with the brain? Do you mean some type of implant? Yeah, like a Neuralink. Do you mean like Neuralink? Yeah. So there are people testing that, not on current astronauts. We're not using that on flight astronauts yet. Okay. And then for balance or injury or weightlifting, has the military started at looking at that for military applications? Yes. Yeah, absolutely. Yes.
Does the training minimize nausea that normally comes with imbalance?
No, not at all. VR makes it worse. The astronauts throw up all the time. So much so they have a code word for it, and it's going for a taco. So we weren't able to get tacos. We weren't able to get tacos in the game. So how we got it in is the code word that the doctors put in the report that the astronaut blew chunks while training in the VR is he went for a taco. Yeah. Yeah.
So I recall reading that the astronauts that were actually on the moon, back, in the 60s, 70s, had to like change their gait. Like it was almost like a weird shuffle to move on the moon. Was that a product of their suits back then that will be alleviated now? Or is that something that will be?
Two things. Yeah, so two things. So number one, it really wasn't the suits, because the suits were basically made for the perfect sort of medium of them. the right stuff guys, and they were all test pilots. So everyone in Apollo had a very similar composition of height, weight, body mass. One of my favorite mission groups is actually Apollo 12. They're not very famous, but all three of those astronauts were best friends. Their mission went perfectly. They accomplished everything they were supposed to. They bought gold Corvettes matching with their titles on them. And they were the ones where we realized that what we were doing was training them wrong. So the issue wasn't anything to do with the suits, and that we were training them to move in moon's gravity wrong. We were able to improve that as we started to have them return and tell us about their experiment, like their experience of the moon shuffle, the moonwalk. But also, we didn't really know what the composition of the moon surface was going to be back then. We weren't sure if it was talc powder or silken or rocky. Are we going to be putting these guys on crush, or is it like, we didn't really know very much. We kind of look back and we like to think that we knew a lot about the moon before we are people there, but we really didn't. So that was another reason. We didn't really know the composition of the surface. Like, we didn't really know what the texture would be, and we didn't train them well. We're not trained properly. I mean, they didn't really do a lot of core development. I mean, they did weightlifting, they did running, but any of you guys that know anything about conditioning, like weight training, swim training, cardiovascular training, it's not the same as balance training. And we were doing no balance training back then, no proprioceptive conditioning, and we were doing nothing for core strength at all. So those two elements are sort of a big part of sort of helping you do micro corrections in your gait, right? You kind of need a strong core. We weren't doing any of that. So really, the tech was actually pretty good for the time. It's terrible now. We need the new spacesuits that we're getting because, for many reasons that have to do with body composition, gender, size, weight, everything. But yeah, no, so to answer your question, it wasn't really the tech, it was the data. We didn't really have good data.
So with your portable system that's going to be on the rovers that go from the gateway, how much recalibration is, those would need.
Yeah, we'll have to have a different technology. So those are based on accelerometers. Accelerometers on the moon are going to give us really bad data. So what we're looking at now, we're looking at cameras. That's all I can kind of say. We're looking at cameras now. We think that's a very smart way. If we can basically create rigs of skeletons of the movement, we can map it and use algorithms to track their changes in gait using cameras. Then they won't have to wear the sensors. We are just looking at them to get it. And we're hoping that will be less invasive to them. We don't want to be bothersome. They've got EVAs, they've got work to do. So as the least amount of invasive, right? And the NASA thing, keep it simple, easy to understand, and don't bother the astronauts as much as you can. So I think that's the direction we're probably going to move to, for at least for the moon and the Mars base, because accelerometers do weird things in space. Can't really use them. Yeah.
Are any other space agencies doing anything similar, or can we get data?
So Europe,
Russians or Europeans?
Okay, yeah. So let's address the elephant in the room, Roscosmos. NASA's crushed about it. At least, you talk to the old dogs, and we get a lot from our partners at Roscosmos. And from what we know, the higher ups are towing the line, but everyone day to day is pissed. They want this over because we have a fucking schedule. Sorry, we have things to do. And this has got to wrap up, because getting Russia out of the gateway, it's not ideal. Want to work with them, and they want to work with us too. But the official language right now is not great. Unfortunately, that may change with politics. That's how we're hopeful that will change. They do have their own stuff. They're proposing making their own space. I really hope this war gets wrapped up before they start down that path. It would make more sense for us to work together on Gateway. But that's just, politics aside, that's just my opinion. I'm in the favor of science, not, so I think most of the people at Roscosmos and NASA are in that same boat. Yeah.
So China is planning to do a space station on their own.
Mm-hmm.
Potential is.
Have you watched their ability to track their own trajectories?
No, I haven't really followed it too much, but I know
they're not great at it. They don't really know where stuff's going to re-enter, where it's going to go. They're not really great. There's some stuff that haven't solved yet. And again, politics aside, we would like them to be better at it. If they're going to put stuff up there, we'd like to work with you. You know, we'd like to work together. And with Europe and Japan has actually stepped up a lot lately with the gateway to cover some of what we need to stay on track, because we're hoping to be on track for 2030s. So barring any other horrific global events that usually slow NASA down, we're hoping for that same target. Sorry, because you had your hand up for a while.
Yeah. Is there any talk about applying this to fall prevention?
Ooh.
Because it seems as though it can be very useful.
If we can get people to use it, I could get my grandma to wear the button. She wouldn't do it. She'd leave it in the kitchen. But no, I mean, I'm not, trying not to be flippant, trying to be funny. But I absolutely
go to physical therapy.
There's a lot that came from NASA in previous generations, that came from our missions, that got commercialized and benefited all of us. I absolutely think that's going to continue. I'm hopeful that this type of technology is helpful for everything. There are physical therapists using VR technology as accessibility tech right now. So wearing a VR headset tends to be comfortable for only certain people, and people with reduced mobility have a big problem with using the controllers for VR. But Access Tech is developing things like changing those controllers, or there's an open source software now that's camera based that we plan to use that basically just captures movement. So if you guys have seen Apple release their new VR set, and their headset has a forward facing camera that captures your hand movement, and that is what allows you to select, right? I think you just make like this motion, and that's basically pressing the enter key. That type of technology is open source, and a lot of people are building off of that. And I think that will be very transformative for physical therapy, right? Taking away these bulky controllers or heavy things and sort of making things be managed through cameras. But again, that's digital signal processing, and, the development of the applications themselves requires a lot of input from healthcare professionals, which means it's a lot of like, how do you take like a customized condition of one patient, let's say with cerebral palsy, and try to make that also be meaningful movement work or calibration for someone with another disability? That sort of finding the aspects that we can track and making technology that's commercial requires us to sort of find this, I don't know, like this thing that we don't see yet that's similar for all of us, even though we may have extremely individual patient conditions. Does that make sense? Yeah. How do we find that aspect of movement or motion that gives everybody like bang for their buck? Believe it or not, the Wii from Nintendo was one of the most transformative sort of game use platforms. Because you could basically stand on a platform and play. Your controller could be a tennis racket. It could be a golf club. And that really did change the mind of physical therapists and occupational therapists around using games to basically rehabilitate their patients. And I absolutely think NASA is all for it. Whatever they can do to help the astronauts recover and condition themselves. Is that helpful answer? Sometimes I go off on tangents.
Sometimes tangents are helpful for finding.
Sometimes. Yeah. You had a question?
Yeah.
Yeah.
About some type of centrifuge work.
So how many of you guys have seen a science fiction movie where they attempt to spin the space station for periods of time to create a simulated form of gravity? Two things. We haven't solved the energy problem there. The International Space Station experiences what we would consider to be brownouts daily and what we would consider to be blackouts all the time, probably weekly. So we haven't figured out that energy piece yet that we would need to make that work. Solar sails don't generate nearly enough current. We do not have enough power. Current battery technology is way too heavy. I mean, it's too heavy.
You can do that on the moon.
Absolutely. Okay. Have you guys seen how we're going to generate energy on the moon base? Like what we're going to do? Oh, you guys got to Google it. All right, it's so cool. So kind of like geothermal, we're going to drill into the moon. All right. And this is how we're going to get water and how we're actually going to get metal. And then we're going to use 3D printers to print what we need in space from what comes out of the moon. We will excrete basically through our process of kind of, you can think of it like desalinization, except we'll suck water out of the particulates that make up the core of the moon, you know, part of the internal mantle of the moon. I don't actually know what that word, I'm not a rock geologist, I'm sorry, but like we're going to drill into it. We're going to extract the water out of it for drinking water, potable drinking water. And then the byproduct of that is a metal that is an aluminate, part of the aluminum family. So we can extrude that, 3D print that, and use that to make tools on the moon. And we have a similar process for generating energy on the moon as well. So our plan is basically take the least amount of stuff that we can to space and figure out how we can use the terrain of the moon to create as much of the habitable environment for us as possible. So this family of projects, that X-HAB, Moon to Mars, is all about how do we make building technology, health technology, how do we make HVAC systems that'll work properly on the moon? You know, it's the nuts and bolts of building civilization technology on the moon with new stuff we haven't come up with yet, or commercializing stuff and trying to reconfigure stuff to make things work so that we can basically have a permanent habituation there. And that includes what you're thinking about, right? How can we make a power plant on the moon that makes the most sense? And current technology isn't exactly there yet. We have some problems solved, but not all of them.
Well, Sandy started to take water.
Yeah.
For oxygen, hydrogen for people.
Right. So that's the same process that I'm talking about. So what will generate the water will also help generate our basically our raw material for building. So I don't have any pictures of it. I can't remember the name of it, but you can Google at Johnson Space Center right now. They have the 3D printed extrusion machine that they plan to bring to the moon and use that aluminate, like that aluminum material, to 3D print a habitat. It looks like it just looks like a turd building. Like it just looks like this long tube, weird. It's very strange looking, but you have to see it. It's, if you just Google like Johnson 3D printed, you know, Mars habitat, you'll find it in a second. Actually, astronauts are currently living in it right now in a 1-year study to see what it would be like to live in a 3D printed habitat that was 3D printed for Mars. So it's an on Earth at Johnson Space Center test of potentially using this 3D technology to create that 3D printed habitat. Yeah. Sorry. Yeah.
You mentioned all the different countries that are key in the space competition programs. Japan seems to have disappeared from the stage. And I'm just wondering.
Well, they're active in Gateway. They're one of the partners for the space station.
We don't hear about in any insight of what their role is, or
I can't talk too much about it. I'm not an expert. I can just say, to my knowledge, they're still active in the programs that we have slated for the future space station, the Gateway project. I don't know about anything else. So I could give you an example. The Gateway will feature a new capture. Have you guys ever seen a movie where the capsule has to fit and line up perfectly, and then they capture it, and then they go, oh, and then they release the pressure, and then they can open the doors, right? Open the ballast doors and open the doors, and oh, we've matched pressure. Okay, so that Rabby, we've designed a whole new one. That is, you know, an AI operated. You don't need to do it by hand. It's completely automated, and it works with American, Russian. It works with everyone's. Like, we're trying to standardize that system so every country's technology can be captured and join up with the Gateway. And Japan is a huge part of generating that. And that prototype is built. The first one is built, and they're testing it in Johnson. So I think we're on schedule for that. I can't talk to what you're bringing up particularly. I'm only familiar with, in particular, that new capture technology.
You don't hear about Japan.
Yeah. It could just be press. It could just be what NASA's choosing. NASA's trying to, raise money for Psyche, and they have Artemis missions going on right now. It could just be what is making it out versus the people who are day in, day out continuing to work on their missions, and they're separate from what's getting press right now. NASA has their own marketing, but I guess it's just they decide. Sorry, did you? Yeah. So, yeah. And they're still active with us, and they are still active with us. So I don't know what you're talking about, but they are. Yeah.
You mentioned, everybody mentions all the countries
working
on these projects.
Yeah.
It just seems like Japan is either absent or an afterthought, and that's why I was curious.
I think that maybe just the media you've heard. I've experienced the opposite. That they've kind of stepped up when we lost our very close relationship with Roscosmos.
That's really what I'm asking.
No, they've stepped up. They've stepped up, actually. Jeff?
Yeah. Have you seen or heard any results of BioSentinel?
Yeah.
That you can talk about?
Sorry.
Next
time. Yeah. When it becomes public knowledge. Whatever you can find on Google is what I know. I'm sorry.
Tony, are there any questions?
Oh, yeah. Anybody online? Sorry, I don't know how to bring the chat back up.
Yeah, someone spilled something up here. I thought it was me earlier, but that's what happened to you. I was like, okay, it wasn't just me.
Yeah, a little bit. Did anybody else have a question? Did I get everybody?
Yeah.
Sorry if I missed you.
I just we were drilling.
Yeah. Mm-hmm.
Are you working with any other universities like that?
Oh my God, yes.
Because I know the big right now where they're drilling very deep.
Oh yeah.
And recirculating water, to create energy.
So every year the X-HAB, so they actually may have been an X-HAB winner. So Cornell is actually interesting that you brought them up. They are part of the grant dispersion for all universities. So if NASA awards your grant, Cornell is actually the gatehouse for those finances. Arizona State University is a gateway for marketing and for language around outreach, right? So not just marketing, but also outreach, trying to teach people what is the Psyche mission, right? So those are just two examples of how all the universities are kind of all in it together, even if we're never really competing. We all kind of have our own little niche, and we're all kind of doing our own thing, and we kind of reach out and we hear, or NASA tells us, okay, this collaboration makes sense. Like RIT in Arizona, I want you guys to work together on this, or Michigan and Cornell, I want, this is cool, so they do attempt to facilitate collaborations, if that makes sense. NASA loves a collaboration. Why? Because they historically have been underfunded, and they need to make collaborations tend to make dollars stretch further. Yeah, exactly. So yeah, I am familiar with what Cornell's doing, mostly because Cornell's the gateway for money for the universities that win the challenge grants from NASA. Yeah, it's great. I mean, everybody loves to have NASA as a client. It just feels so positive and forward looking, which can sometimes feel hard. Did anybody have any questions online? Okay. All right. Back to work, I guess. Thanks, guys.